Alright guys, looking at the second problem here that we are looking at on our take-home quiz. Hopefully if you found this video, it's solving systems of equations by substitution. I've avoided doing an example like number 4 that was like on your practice quiz, your second practice quiz, your actual quiz, and now again on the take-home quiz. Most people did really good with that. I don't feel like I should make a video for something that most people got 10s on. So you guys were really good at that one. These were the ones that you struggled with, and this one was the one that was worth 15 points anyways. So I'm going to spend my time focusing on the one that was like question 5. By now you've looked at the two equations that are on the screen here, and we have equation 1 and equation 2. And you're going to have to mess with one of those two equations in order to solve this this set of system equations. And if you're thinking to yourself that you want to mess with equation 2, you'd be exactly right. The reason we're going to do that is because there's a single x already set up here for us. We could mess with equation 1 and get something set equal to y or equal to x, but we would have to divide something by 9 or divide something by 3, and it's just going to get messy. It's a lot more work, and we all know how you guys feel about extra work. So we're going to take equation 2 and we're going to change it into something else. We want to get x by itself, so to do that right now there's a plus 3y that's sitting here with the x, and in order to get rid of it and move it to the other side, we're going to have to do the exact opposite. It's called inverse operations. We're going to move the 3y over to the other side by subtracting. I like to put it towards the front here, because when I rewrite this equation, this second equation here, I'm going to rewrite it as x equals negative 3y plus 4, because that 4 there is a positive. So that's going to make that a plus 4. And now that I have this new equation written for equation 2, I can sub this now into equation 1 wherever I see an x. And some of you guys ran into the problem of subbing in your x's for y's or vice versa, but I'm subbing this new second equation into equation 1 wherever I see an x. So now I'm going to go ahead and write the first equation here with the second equation substituted in place of x. So it's going to be 9y minus 3, and now again I'm going to change the color of the ink to match what I should write instead of x. Remember, x is now equaling negative 3y plus 4. So I'm going to write in parentheses negative 3y, I should put my negative sign here, negative 3y plus 4. I'll close my parenthesis. And that's going to equal positive 24. Now the one thing that I really want you guys to double check for on the quiz, if it's happening, is the sign in front of distribution, because most of us go on autopilot. We just start distributing, and when we're reckless like that, we miss this minus sign in front. So one good piece of advice is double check when you have distribution for any minus sign that might be lurking in front, and let's change it to a plus, and the 3 will become a negative, and now we're distributing negative 3 instead of positive 3, and that does have an impact here on our second distribution here to the positive 4. So when we distribute, we are going to get 9y like we had before. Negative 3 times negative 3y is going to give us positive 9y. And now negative 3 times positive 4 gives us negative 12. So that's where the difference would come in for us. That's where the difference would come in for us. And it's going to all equal 24. Now, I need to look for any like terms that I might be able to add, and I see like terms right here and right here. Same signs add them up, different signs subtract. Those are both positives. So it's going to be an 18y. Now the other thing, if I'm going to get 18y, it's going to be minusing 12 equaling 24. I might as well just take care of this 12 right now since I'm running out of room down here. And I'm going to add that to the other side. So, adding the 12 to the other side. Adding the 12 here to the other side. I'm going to draw a line. And go back to the black ink. And we said that this was going to equal an 18y. That's what's going to be left on this side of the equal sign. And over here, same signs add them up, different signs subtract. Same signs add them up, they're both positive. It's going to be positive 36. This is looking nice for me right now because I know that when I divide both sides by 18, I am going to get y equaling positive 2. And of course, I'm going to pat myself on the back like I always did in class, think that I'm done, and get 50% of the answer correct. That's right, you guessed it. We need to get an x value because our final answer should be written as a coordinate. And what I'm going to do now is take this y value here and plug it right on back into, you guessed it, this equation here to get my value for x. Okay, so going back to that problem there, I'm going to say that x now equals negative 3 times a positive 2. Remember, I'm using that positive 2 value for y instead of putting y. So it's a positive 2 there, and then it's going to be a plus 4. Plus 4. Okay, x equals negative 6 plus positive 4. Same signs add them up, different signs subtract. Different signs subtract. 6 minus 4 is 2. Keep the sign a larger number, then you'll be exact. This is the larger number, it's a negative. So I'm going to get x equals negative 2. No way. We have an x value now, we have a y value now. And so we can write our answer as a coordinate. X value, of course, first, because in the alphabet x comes before y. And it's going to be written negative 2, positive 2. Hope you found this video useful. It certainly looks like question 5 on your take-home quiz. And that problem, again, is worth 15 points. It is the highest point value problem that you have on your take-home quiz. So please find your way to this video, tell a friend, and get all the points that you guys deserve. Good luck.